Okay, this is Diego Perez from IMEN Technology Center. And as Rames already pointed, I'm going to present the person detection and tracking or the local heat map for road optimization and planning. So the motivation here for developing this module is that usually when you deploy an AGV, any kind of AGV, usually have some shared space between human and robots. Even you have corridors or you have some paint in the shop floor limiting the access, at the end you have always interference. Some could be avoided, others not. And also navigation areas are predefined, virtually programmed, or with lines or with tracks. We are focusing on virtual programming here. The main problem with deploying or with optimizing the movement on the path extraction and planning is that we don't have data from the environment. We could have, if we have this target approach that Martin presented today, but we're rather having non-wearable device approach in terms of monitoring the space, a given space with cameras. So the idea is to get optical navigation roads using real-time environment information. We are talking about path planning for the AGVs, not material movement in this case. The information could be also used for local obstacle avoidance. If we are performing some kind of navigation that are not fixed to a predefined road, that robots may have some kind of local obstacle avoidance because they have some flexibility on the way they can approach the obstacles and avoid them. The information coming from the cameras could be used for anticipating, to implement an anticipated behavior for obstacle avoidance. So the approach is to install cameras, stereo pairs. They have to be placed monitoring the same area, but it's not necessary to have like a very precise localization in these terms or installation. You can just put the cameras there and then you perform the calibration between them with just a regular procedure. So here we see that we are monitoring a working cell, an open working cell, and a huge place on a shop floor with only a couple of cameras, some medium resolution cameras around 2 megapixels and an optics of 4.5 millimeters, more or less. And we obtain the occupancy data for the grid map, for the navigation map of the AGVs at a rate around 4 hertz, and it's sent to the central sensing and perception module of the OPIL library. So regarding the architecture, what we have is a tracking node that it's a sensor node for the OPIL library. We detect the people using 2D images. We detect the persons in both images, but we don't perform any kind of personal identification. We don't use personal data here. So we identify people as a general abstraction, and then we perform the tracking between consecutive images from the same camera and synchronized images from both cameras. So we have like a double synchronization here just to extract the 3D position or the position of the person in the environment. So we have the information about the occupied positions in the grid map, in the local heat map. And this is the information that it's forwarded outside the tracking node. We don't use personal data. The integration in the OPIL library, the only thing that it's done for the occupancy update is to span the person dimension. As for the tracking node, you only obtain a point, the point that it's been occupied by the person. So you have to span the dimensions and communicate with the central sensing and perception system through FIROS. In this case, we connect to the context broker with ROS bridge for figure. So we have the local heat map of human occupancy with the stereo pairs tracking consecutive images on each camera and perform the pair detection in the couple images. We have to identify who is who in terms of multi-person detection. This is the tricky part here. Detect a person is quite easy. You detect several persons and know the correspondence between all of them in different images is the hard part on the implementation. And then we obtain the position in the map, in the navigation map. And this is information that it's forwarded to the context broker. Talking about how OPIL use this information, it's transparent. The central sensing and perception module was modified to accept non-NGV information, because currently this module, or previously, currently it's already working, but previously it was working only with information coming from the sensor, from the NGVs, the laser scanners, or the environment sensors installed on the NGV. And when forwarding this information to the context broker, the planner, the path planner already considers this occupancy local heat map. Nodes are removed. For the navigation, OPIL use like a grid of different nodes that sets like a navigation or potential navigation path. So what the system do is to remove these nodes dynamically. You can see here that if we detect a person in this place, nodes will be removed from the available navigation space in real time. So this is what is the aim of monitoring the space with the tracking of persons, to monitor the current state to get optimal path depending on the distribution or the occupancy of the shared space between AGVs and humans. And so this is my presentation. I don't know if you have any question.